Alright, so the warm-up here is just making sure that we understand order of operations. Okay. We would want to do what's inside of parentheses first. So we would want to take care of everything on the inside here. So I can take the 3 plus negative 7 and get negative 4. Negative 4 divided by 2 is negative 2. And then I'll take 3 times negative 2 and get negative 6. Right. Similar idea over here. Negative 17 plus 6, that gets me negative 11 divided by 2. That's not a whole number, that would just be negative 5.5. Right? And then I can multiply by 24 and get negative 132. You good with those? Mm-hmm. Alright, then today we are going to look at arithmetic series. Okay? Before we do that, let's just look at what a series is. Okay? There are series on Netflix. This is a little bit different idea, though. So a sequence that we looked at on Monday was just a list of terms. Right? A series is the sum of a sequence. What does sum mean?
You add.
Right, we're adding them all together.
Yeah.
So it's like taking a list of numbers and adding them all together. Okay, that's what a series is. So we are going to look at arithmetic series today. So we have a formula for the sum of an arithmetic series. We denote it with a capital S sub n. So we say capital S sub n is equal to n times a sub 1 plus a sub n over 2. So what this is saying is to get my whole sum, right, so this is the entire sum, I take the number of terms, so this is number of terms.
Is that a capital S?
Yeah, capital S, the little sub n.
It's a 5.
Do you want me to fix it?
No, I'm just joking. It still looks like 5.
That looks more like 5 minutes.
It's fine.
So then here, a sub 1, that is the first term in our sequence, and a sub n is the last term. Okay, so to get a sum of an arithmetic series, or I guess we could say to get the sum of an arithmetic sequence, which is a series, I take the number of terms times the first term plus the last term divided by 2. Okay, so this looks pretty similar to our warm-up, right? That's why we practice that arithmetic in the warm-up. So let's take a look at a couple of examples.
Oh.
I'll leave the formula down there for a second. All right, so to use this formula, I need 3 things, right? I need the number of terms, the first term, and the last term. So if I'm looking at how this is presented, well, they tell me the number of terms, right? I know that n is 16. That's how many terms I want to add up here. So n is 16. What's my first term? Negative 17. What's my last term? So in this case, my a sub n will be a sub 16, right? I want the 16th term. I want to add up the first 16 terms. So in this case, I want to find a sub 16, 16th term. How do I do that?
You gotta do it. You told me yesterday with one game of something. Did we didn't one form?
Exactly. We got to do that stupid thing we did yesterday. Alright? So, to do that, we used this formula. Right? A sub n equals our common difference times n minus 1 plus a sub 1. So let's write our rule like we did before. Right? So what is my common difference here? What number am I adding or subtracting every time to get to the next term?
4.
Almost.
Oh, negative.
Negative 4. Right? I'm subtracting 4 every time. So my common difference would be negative 4. And if I'm just writing the rule, I'll leave it in terms of n, plus my first term, which is negative 17. Right? So I can just say minus 17, or we could say plus negative 17. That's all right, too. Now, I want the 16th term. So I'm just going to plug 16 in for n. So I'll say a sub 16 is negative 4 times 16 minus 1 minus 17. So what do we get for that?
Oh. Minus 17.
Negative 77. So now we've collected the 3 pieces of information we need. Right? We have our number of terms, the first term, and the last term. Now I can find the sum.
Oh, and then now we have to go and subtract 4 from all of them.
Well,
we
no.
can just do that,
So,
honestly.
yeah, now I'm going to use this formula, right? I've collected the 3 pieces of information I need to plug into my sum formula here. So I can say S sub 16, that means the sum of the first 16 terms, is equal to the number of terms, so 16, times the first term, plus the second term, divided by 2. Madness, right? So, what do I get? What is the sum of the first 16 terms in this sequence? What is it? Negative 47?
Oh, no. Negative
Negative 888?
Yeah.
That sounds a little bit more reasonable.
Ooh, salsa. Tripping.
That's not what you get. What do you get? Alright, so how are people getting negative 47?
I think they're not putting parentheses around negative 47.
We just forgot to type that.
Oh, okay. No, I mean, negative 17 minus 77 divided by 2 is negative 47.
Plus negative 77?
Yeah, then times 16 would be negative 752.
Yeah.
So what did you do?
Me?
So the correct answer should be negative 752.
I put negative 17 plus parentheses negative 77 parentheses divided by 2.
No, so if you're going to do that, you have to put parentheses around the whole thing.
Then
Yeah, you just told us to divide the 77.
Roger that, oh boy.
So if I were to add the first 16 terms in this sequence, I would get negative 752. Feel okay with this so far? Yeah. Let's do one more together here.
2 more.
One more, and then I'll have you guys try. Alright, so again, I need to collect these 3 pieces of information. The number of terms, the first term, and in this case, the 14th term. Okay? So I want n, a sub 1, and a sub 14. So what's n? What's n in this problem?
Oh, yeah.
14.
14. What's a sub 1? 10. Now I need to do a little bit of work to find my 14th term.
Do the stuff.
We gotta do the stuff. Okay? So I can say a sub n equals d times n minus 1 plus a sub 1. So a sub n is, what's my common difference here?
Oh, 8.
8.
Plus
Okay. Yeah, it'll be a positive 8. So going up by 8 every time. And then we said my first term was 10. So this is my rule for this sequence. Then to get the 14th term, I will just plug in 14 for n. So what does this give us? What is the 14th term?
Oh. Oh.
114. So now we have all the information we need to find the sum. So I can say S sub 14, the sum of the first 14 terms, is equal to n times a sub 1 plus a sub 14 over 2. So what is my sum of the first 14 terms here?
$8.68.
868. All right, how are we feeling? Is it making some sense?
Yeah, would if my eyelashes look totally
All right, you guys try number 3 here. Find me the sum of the first 18 terms.
It's 100 terms.
You could. They do the same work, right?
It's infinitely expensive.
We are going to look at some infinite series.
So I just want to be able, like, lazy, right on, done this.
Just list them all out.
7, all of them.
Yeah, I mean, if you want to add 7 18 times, you could do that. I mean, I think this would be less work, though. But yeah, you can do it that way.
I'll need that.
However you want to get these 3 pieces of information.
You.
The number of terms, the first term, the last term.
I always feel so judged and pressured. Every time she comes over, I'm don't want it.
It just looks so.
Yeah, you are judging me, and I feel it. I feel it in my soul. Don't want it. Keep judging me. Keep judging me. Look at judge me.
She's laughing at you.
There's one.
Judge Marshall.
You are high-ranking milk. Watch your mouth.
I stand right next to you.
I know you like
Oh yeah, sorry.
No, I just wanted to make sure that
Yeah.
we're still using it.
you can have the big X one there. Still, and you
Yeah.
can do-
Yeah, I'll write that.
Even though I have it directly on my paper.
So,
Very chicken spicy.
I'll take the pick out of here in a sec.
Oh no, this one's.
Oh, yeah.
Oh.
Hey, your setup's on.
Oh, no, it's not.
Oh, you did mine. Oh, yeah, you did mine. Yep, yeah.
Shoot.
What, dude?
Oh, I see why I subtracted. Because when we did the negative up here, or I didn't add the plus sign, so I just.
Oh, you want to do 4 as well?
Yeah, you can go ahead.
Okay. Oh, I sliced my finger open.
That's not
Yeah, I was doing the dish. Huh? Oh, I was washing a pan, like a casserole dish. There's like food in it because, of course nobody likes dishes, so except me. And I struck really hard, my hand slipped, and it was a piece of, dried up food that cut my finger. Yeah, gross, I know. Disgusting. All I wanted to do was make my cheese potatoes. Those turned out really good. 5.
was one.
Yeah. That was I love cooking. Y'all ever want me to come over and just cook? I do. We had steak and cheese. Oh yeah. Uh-huh. Why do you think he's fat? You make him yeah. He's always like, your cooking sucks. Hey, why do you eat it all the time? Don't try to pull, oh, he's just being nice. Oh no, this boy. I've never seen somebody eat so many tacos. He loves tacos. And potatoes. I haven't seen you in a few days. No. I see there was one day you were walking home and I drove by you and I honked at you. And you didn't even acknowledge me.
Right.
Yeah, that's what I thought. You were like,
Hold up.
I was almost freaked out. I forgot that I just left my debit card in my car. So I passed it in my case. I'm like, my speed reward card's in here, but where's my debit card?
So,
Man. Tyler's a W. I want McDonald's. I didn't get home till midnight. I got home, he's sleeping. I wake him up to eat, and nope. he goes back to bed, and I'm like, he literally stopped losing 3 times. The last night, yes, he's laying on his back, and I'm like, okay, you need to like roll over on your side because you're scared of losing. Shut up! Gosh! I'm like, I'm just trying to save you.
Oh, I just stopped breathing.
I don't know, like he snores really bad. I'm gonna have to take a video of him snoring one day. Send a video. Don't trash on. See what happens then. But yeah, like,
You're really smart.
it like scares me.
Alright, so for number 3, I got 1485,
Yes.
and number 4, I got 338.
Yes.
You feeling okay with these?
Absolutely.
Alright, let's flip it over and learn some Greek.
Cricket.
Oh god, I don't even like the way this looks.
Well,
Looks hard.
Alright, so this on the back is just another way of writing a series. Okay? It's called summation notation. Right? Summation. Sum just means adding things, right? It's just another way of writing a series. So summation notation looks like this. Right? We use
Whoa.
this big Greek letter.
Is it supposed to be the Greek picture?
I'll straighten it out a little bit.
See how the top ones are like 45?
Is that better?
Yes.
Yeah.
Alright, so generally we write it like I'll write it like this. Alright, so this is just a generic example. This down here, this number, whatever's down here, and most of the time we'll look at just 1 as being the number that we start with. Okay, so this is the first number to plug in. Yes. I equals 1 to n.
It's an I.
Yeah.
Man, you got a big
Whatever number's up top here is the last number to plug in. And then this right here is our rule. Right? So what this all means, okay, this is just a compact way of expressing a series. So if I look at this first example, this is telling me I'm going to plug in every integer in between 1 and 5 into this rule and then add all those numbers together. So this is saying plug 1 into this. So I'll have 4 times 1 squared minus 2. Then plug the next number in. Plug 2 into this. So I'll have 4 times 2 squared minus 2. Then plug the next number in. Plug 3 in. So I'll have 4 times 3 squared minus 2. Then plug the next one in. So 4 times 4 squared minus 2. And then it tells me to stop at 5.
that's so much. I don't.
So the final number I'm plugging in
Oh,
is 5. Right? So it's saying plug 1, 2, 3, 4, and 5 in, and then add all of those together.
Now, would it be easier to do it this way, or would it be easier to plug each one of those in as an X, and then we keep plugging them in?
Oh my god.
Wait, what do you mean?
I could do like the, I don't know what the button is. Oh, like 1 store as X, and then like just type in 4, like the 1, 2, and then just put X into the number instead. You'll be able to see it, and then you can write it out.
Oh, I think I see what you're saying.
Instead of doing all that over and over.
Yeah, that would probably work.
Well, I mean, would that be easier than doing it just like that? Are you gonna write that, solve all those and then write them down?
Yeah.
Okay, then I think it'd be easier.
So we can do this one piece at a time, right? 1 squared is just 1. 4 times 1 is 4. Minus 2 would be 2. 2 squared is 4. 4 times 4 is 16. 16 minus 2 is 14. 3 squared is 9. 9 times 4 is 36. 36 minus 2 is 34. 4 squared is 16. 16 times 4 is 64. 64 minus 2 is 62. 5 squared is 25. 25 times 4 is 100. 100 minus 2 is 98. So now I can add all of these together. What would this sum be if I add all 5 of these numbers together?
Oh yeah, you can plug in there.
So what is this sum?
210.
210? So we can say this weird looking notation, the summation notation, is equal to 210. Okay, it's just saying get me these 5 numbers and add them together. That's equal to 210. Okay? Number 2 is a little bit more straightforward. Okay, it's a little bit easier to solve. So I want you guys to try number 2 here.
Oh.
Okay, there's going to be 4 terms. Right? We're starting at 1, going all the way up to 4. Okay, so try number 2 here. Plug in 1, 2, 3, and 4. And add those numbers together.
You can do all this without writing it out. All you gotta do is write the first one, put the X in, and all the numbers are laid out for you. And you just keep going down and punching them in. So you can't write anything down. So if you want to be a cool guy and do writing, listen. Right, study, either my mom.
Mikey. Isn't he annoying?
Okay, Brie.
What?
About 4 days. You come back to bash me.
No,
All I done.
I was just joking. No. You didn't even hit me up to see if I was okay or
I know you're okay.
dead or
You're a strong woman.
you're like, alright, she posts on Facebook, she's fine.
Start checking on my sister. My sister doing good. He posts a whole bunch of Facebook pictures on her.
Oh, this is, I'm sorry.
She posts a whole lot though.
That seems kind of easy.
Well, can't you just put the
Kind of.
I'm
Just
not going to go through all my work.
No one.
It's true.
It's not my
All right, I got 50 for this one. So we got.
Yes.
All right. Now let's get a little more specific.
No.
Take a look at the sum of an arithmetic series. All right. So here we want to get a few more terms. Right. Here, if I want 20 terms, it's not really going to make sense to write out all 20 terms. Good thing we have a formula. Right? I know that the sum of an arithmetic series looks like this. Right? Same idea as what we did on the front. I need 3 pieces of information. I need n, I need a sub 1, and I need a sub n. In this case, my n is 20. Okay? So I want the number of terms, the first term, and the 20th term. Right? Well, number of terms is 20. How would I get my first term and my 20th term?
Would you do what we did up above?
Yeah, we're just going to plug 1 into this rule. And then I'll plug 20 into this rule. That'll give me my first term and my 20th term. So if I plug 1 in here, that'll be negative 4 times 1 minus 3. So negative 4 minus 3 is negative 7. My first term is negative 7. Then to get the 20th term, I will plug 20 into this one. So negative 4 times 20 minus 3. Negative 83. So now I have the 3 pieces of information I need to use my formula. So I can say S sub 20, the sum of the first 20 terms, is equal to 20 times negative 7 plus negative 83 over 2.
Oh.
So what do we get for that? Negative 900. Les?
What's that squeaking? Much.
So, when we have an arithmetic series presented in summation notation, I actually think it's a little bit easier to find the sum than
Yeah.
how it was presented on the front. So let's do one more together here. So my 3 pieces that I need, and the first term, and in this case the 10th term. So n will be 10. A sub 1, I'm going to plug 1 into my rule. So 6 times 1 minus 15. 6 minus 15 would be negative 9. Then if I plug 10 into my rule, 6 times 10 minus 15 would be 60 minus 15 is 45. So now I have all of the information I need. My S sub 10 will be 10 times negative 9 plus 45 over 2.
Oh my God.
You like my writing?
And I like your
Thanks. So what do we get for the sum of the first 10 terms here? $180. Thanks. Alright, we feeling okay with these? You guys go ahead and try 3 and 4. Number 3, find me the sum of the first 50 terms in this series. And number 4, 14 terms.
So,
Well, yeah, same.
thanks. Oops.
Oh, you weren't done?
No, I was just looking back
So are you not reading it?
Awesome.
I never read it. I've watched the movie.
Oh, the book is really good. A lot of different things compared to the movie, but like how things turn out. But the book is really good. It's one of my favorites. That's why I wrote it for it. So read. See. Hockey speak Espanol.